Hi everyone, I'm now going to go over the compositions and inverse functions package. Basically, these are a set of IB questions that will really help you on the test and have a good understanding of composition and inverse functions. Alright, so let's look at number one. Let f of x equals square root of x plus 4 and all that information. Find g of f of 3. So the best way to do this is first just find g of f of x and then plug in the value for x for 3, or 3 for x. So g of f of x looks like this, which really just means g of f of x, which is g of f of x is square root of x plus 4 of x plus 4. And all we're doing now is we're taking this and we're going to plug it into x squared. This is x squared. You can't really see it, but it's x squared. So in other words, this just becomes something squared, and that something is the argument over here. So it's equal to x plus 4, and that squared is simply, square root of x plus 4, and the square of a square root is simply x plus 4. So that's g of f of x. Now if we want g of f of 3, right, we've just already found g of f of x, which is x plus 4, and all we have to do is plug in 3, so 3 plus 4 is equal to 7. All right, so we're done with that one. I'm going to erase this because I just need some room to find f inverse. But let's just do that. So, okay. So f inverse of x. So f inverse of x. We have to find that. So in other words, this is f of x. So y is equal to square root of x plus 4. Okay. So to find f inverse, you have to switch x and y. So x equals y plus 4 square rooted. And then in order to isolate y, first we have to square the square root, so it becomes x squared is equal to y plus 4. If you didn't understand that, what I did was I just squared this and then I squared that. And so the square root and the square cancel each other out. And then finally, if you just isolate y, it's equal to x squared minus 4. And the final way to write it is, right, f inverse of x is equal to x squared minus 4. And that's what you get. Now, and that's what you get. Write down the domain of f inverse. So once again, I'm just going to erase, I'm going to erase this. I'm just going to keep this for a second. So you have to remember that the domain of f inverse is really the range of the original function. The domain of the original function is the range of the inverse, and the range of the original function is the domain of the inverse. So we have to find the range. So the best way to do this is to draw a sketch. So if you draw a sketch, this is x plus 4, which means that it's to the left here, and it goes like that, right? So the range in this case is y is greater than or equal to 0, because it basically starts at 0 and then goes upward. So y is greater than 0. So the domain of f inverse is simply x is greater than or equal to 0. All right, so that's the solution for that one. And now I'm going to move on to number 2. All right, number 2. Consider f of x is equal to square root of 5. Find f11. Okay, so this is really easy. You just have to plug in f of 11 is really just equal to square root of 11 minus 5, which is equal to the square root of 6. And we can't simplify that, so we just leave that like that. F of 86 is basically you just plug in 86 for x right there. So minus 5, which is the square root of 81, which is equal to 9. So we're done right there. And f of 5 is basically the square root of 5 minus 5, which is equal to the square root of 0, which is equal to 0. So that's that. Find the values of x for which f is undefined. So this is an interesting question. So basically a good way to do this is sort of to draw a sketch. So let me draw a sketch of this. So this is x minus 5, so it's to the right. So here's 5, and it goes like that. So they're asking for the values of x for which f is undefined. So x is defined from 5 onwards. However, there's no value of x to the left of 5. So in other words, the parts where it's undefined is x is less than 5. And it's not equal to, because if you equal it to 5, as we did over here, f of 5, it's equal to 0. So it is defined for 5, but not for any value less than 5. Another way to think about it is that if you put 5 over here, 5 minus 5 is 0. So anything less than 5 will make this square root, the argument in the square root, negative. And you can't have the square root of a negative. So therefore, the parts where it's undefined is x is less than 5. Now I just need a little room to do c. So let g of x equals x squared. Find g of f. So g of f of x is equal to g of f of x, right? So it's g of f of x is square root of x minus 5, right? And remember, all we're doing is just taking this argument right here and plugging it right back into x. And so, if I just get myself a little bit of room, really it's something squared. So it's the square root of x minus 5, which is equal to x minus 5. So that's what this is. All right, so the answer to this one is simply x minus 5. Now, just to make some more room, I'm going to erase all of this, but you can always scroll back in the video and see how I did that. Okay, all right, so number 3. Let f of x equals 3 of x. Let g of x equals 2x minus 5. H of x is f of g of x. So find h of x. So since they said it's f of g of x, really we just have to do f of g of x, which is basically g of x is 2x minus 5. So f of 2x minus 5. And again, all we're doing is taking this argument here and plugging it right into that x over there. So it's equal to 3 times whatever the argument is. So 3 times something, because that's 3x, and that something just happens to be 2x minus 5. So we can expand this, and it's equal to 6x minus 15. So this is equal to 6x minus 15. Okay, find h inverse of x. So you might think that this is a little confusing. Do I have to go to f of g of x? No, you don't have to. You've already found h of x, which is 6x minus 15. So to find the inverse, this was the original function, 6x minus 15. All we have to do is switch the x and y, and then solve for y. Right? So then this becomes x plus 15 equals 6y, and so y equals x plus 15 divided by 6. So finally, to write this, to figure out what h inverse is equal to x plus 15 divided by 6, and this is our answer. Okay, once again, just to make room, I have to erase this. So we've done A and B, and you can always scroll back in the video to figure out how we got that. So I'm just going to erase this right now just to make some room. Okay, let f of x equal 7 minus 2x, and that. So find g of f of x, so straightforward. So g of f of x, so it's g of 7 minus 2x, which is equal to, again, remember, as always, you take this argument right here and you plug it in right into, we're doing it into g, so right into the x over there. So what that means is it's something plus 3, and what is that something? 7 minus 2x. So it's equal to 10 minus 2x, and so that's what g of f of x is. Now write down the inverse of g of x. So basically, y equals 10 minus 2x. So if you want to find the inverse, just switch them. So x equals 10 minus 2y. And then if you want to solve for y, basically the answer is y is equal to, I'm just going to do this really fast. It's going to be x minus 10 divided by negative 2. So our final answer is g inverse of x is equal to x minus 10 divided by negative 2. And so that's the solution for this one. Okay, find f of g inverse of 5. So like I said before, if you're ever given something that's with a number to find out, just first find f of g inverse and then then plug in 5. So f of g inverse basically looks like this. It's a little bit lagging. Okay, so we just found out that g inverse is really x minus 10 divided by negative 2. So it's f of x minus 10 divided by negative 2. And then what you're going to do is you're going to take this argument right here and plug it right into f of x over there. So you take this argument right here and plug it right into right there. So what that's equal to is simply 7 minus 2 times x minus 10 divided by negative 2. Okay? Divided by negative 2. So then we just have to simplify this. So this is equal to, if you observe over here, the negative 2 and the negative 2 will cancel out. So you're left just with positive 1. So it'll be 7 plus x minus 10. So just to clarify how I did that, this will cancel out with that, and you'll just be left with positive 1. And we can simplify this a little bit more to equal, so 7 minus 10 is negative 3, so it's just x minus 3. All right, so, and that's the solution. Okay, sorry, when that's not a solution, because that's just f of g inverse of x. Now we need to plug in 5, so f of g inverse of 5 is simply 5 minus 3, which is equal to 2. So the answer is 2. All right, so the answer is 2 for part C. All right, number 5. Let f of x equals x squared, let g of x equals 2x minus 3. Find g inverse. So, okay, g inverse, that's straightforward. Y is equal to 2x minus 3. We switch x and y, so x equals 2y minus 3. It becomes x plus 3 is equal to 2y, and therefore y is equal to x plus 3 divided by 2. So finally you write, it's not f inverse, but g inverse this time. So finally, your last step will be to say that g inverse of x is equal to, because they asked for g inverse, is equal to x plus 3 divided by 2. Okay, so that's that one. I'm just going to erase it because I need to make room for the second part. So you can always scroll back and see how I did that. Find f of g of 4. So first, always just find f of g of x. So f of g of x, right, is equal to f of g of x right there. And g of x, as we said, is 2x minus 3. So f of 2x minus 3. And remember that you just take this argument right here and then you plug it right into the x and the f. So what this is going to equal is simply something squared, and that something happens to be this argument, 2x minus 3. And you can just leave it like that. You can just leave it like that. You don't have to expand it. Now, we want f of g of 4. So f of g of 4 is equal to 2 times 4 minus 3 squared. So that's 8 minus 3. So it's 8 minus 3 squared. So that's 5 squared, which is equal to 25. And that's the answer for this one. All right, I just have to erase this because I need some room for part 6, for number 6. So I'm just going to erase all of this. But again, you can always scroll back and see, how I got that answer. All right, let's scroll down a bit. All right. Okay, let f of x equals that, g of x is that. Find f of g. Okay, so it's easy enough. F of g of x is f of x minus 1. And you take this argument, as always, okay, and then you plug it in right into f. So you write into that, okay. So if you think about it, what that means is really it's something squared plus 4, and what that something is simply x minus 1, okay. And honestly, I would just leave it like this. This is in vertex form. I would leave it like this. You don't have to expand it. So it's x minus 1 squared plus 4. You can just leave it like that, and that should be fine. Now, I'm just going to erase this because I don't need it. Okay, here. All right, so then now, the vector 3, negative 1 translates the graph of f of g. So in other words, this is f of g right here, this x minus 1 squared plus 4. So it translates the graph of f of g to the graph of h. So it takes this and translates it to some graph h. The question now is, find the coordinates of the vertex of the graph of h. So let's first describe the transformation of h in terms of f of g. So this is what I mean by that. So h of x, really, it's just taking f of g, which is this, okay? F of g, and then it's moving it 3 to the right and 1 down. So really what we're doing is we're taking f of g, okay? We're taking f of g and moving 3 to the right. So remember, if you move it 3 to the right, it's x minus 3, okay? And we're moving it 1 down, so it's negative 1, okay? And as always, I just need to erase this arrow here, but you'll see another arrow just come up in a second. So as always, all we're doing is we're taking this argument here and plugging it right into that x over there, okay? So what that means is we do something, it's something minus 1 squared plus 4. Okay, actually, you know what? I'm going to do it in a different color. That way it sort of makes sense that way. So I'll just do it in a different color. So let me just use green for a second. So first, I'm focusing on this function here. All right. So all I'm doing is it's instead of this x, we're going to take that something. I'll write what that something is in a second. Minus 1. So minus 1. Okay. Squared, because I'm just following that. And then plus 4. So there's that plus 4. Okay. So I've basically done this part. Okay. But then don't forget that there's this minus 1 at the end over here. There's minus 1 over there. And there's the other thing, which is that something, right? So that's a something that I plug into the x. So instead of x, I'm going to write x minus 3, okay? So now all we have to do is just simplify this, okay? So if we simplify this, we really get x minus 3 minus 1 is minus 4, okay? And plus 4 minus 1 is simply plus 3, right? So the question says find the coordinates of the vertex. Based on this, the vertex is 4, 3. So it's 4, 3, right? And that's how we get the solution of this one. All right, now show that h of x is equal to x squared minus 8x plus 19. All you have to do is just expand this, and then that's how you get it. So if we expand it, x minus 4 squared, you can do it many ways. I'm just going to do it directly. It's x squared minus 8x plus 16 plus 3. And then if you expand that and simplify, it's 8x squared minus 8x plus 19. And that's what you get right there. So we're done with that. Okay. All right. So number 7. The functions f and g, are defined by this and that. So this notation right here, all it means is f of x is equal to 3x, and g of x is equal to x plus 2. That's all what it means. There's nothing really fancy about this or anything. It just means f of x is 3x and g of x is that. Find an expression for f of g of x. Okay, so straightforward. Let's do that. So f of g of x, so f of g of x, so g of x, right? And so what that is equal to is simply f of x plus 2. And as always, we take the argument here, okay, and then we plug it right into there, okay, so which is equal to 3 times x plus 2, because instead of that x, I'm now substituting with x plus 2, which is equal to 3x plus 6. All right, so this is equal to 3x plus 6. I'm going to erase this because I need room for part B, but again, always scroll back and see how I've done this. Okay, so now let's do this one. So find f inverse of 18 plus g inverse of 18. Okay, so in order to do that, first we have to find f inverse of x and g inverse of x. So we have f of x is equal to 3x. So in other words, y is equal to 3x. So to find inverse, you switch the x and y. This is equal to 3y, so y is equal to x over 3. So f inverse of x is simply x over 3. Let's do the same thing with g of x. So g of x is equal to x plus 2. So y is equal to x plus 2. Switch x and y, so x equals y plus 2. So y is equal to x minus 2. So g inverse of x is now simply x minus 2. So now it's simple. If you want f inverse of 18, so this is equal to f inverse, you plug in 18 over here. So it's 18 divided by 3 plus 18 minus 2, okay, which is equal to 18 divided by 3 is 6, so this is 6, And 18 minus 2 is equal to 16, so it's plus 16. So 16 plus 6 is simply 22, and we're done. So the solution for B is simply 22. All right, so I hope that made sense. You have to first find f inverse of x, and then g inverse of x, and then sort of go from there. Okay, let's do number 8. Let f of x equals x cubed minus 4 and g of x equals 2x. Okay, so you've never probably seen x cubed minus 4, but the principles of how to do this are essentially the same. Like you know how to do this problem without even having to know what x cubed or looks like. So, like I said before, always find g of f of x first, and then plug in -2 at the end. So g of f of x is equal to, what's f of x? Is simply x cubed minus 4. So it's x cubed minus 4. And all we're doing, as always, is you take this argument and you plug it right into the x value in g, right? So it's equal to 2 times x cubed minus 4, which is equal to 2x cubed minus 8. And that's okay, and sorry, that's not the solution, because now we have to plug in -2. So g of f of -2 is now equal to 2 times -2 cubed minus 8. If you observe, -2 cubed is actually -8, and -8 times 2 is -16. So it's -16 minus 8, and -16 minus 8 is -24. So the answer to this question right here is -24. So remember, the way I did it was, even though you don't know what x cube even looks like, or maybe you do, but if you don't, it doesn't really matter. All you're doing is taking one argument and plugging into another. So plugging into the x of the other. And so we get that, and finally just plug in -2. And you guys know how to do this, so it's equal to -24. All right, find f inverse of x. Okay. So it's really same deal here. So find f inverse of x. So we have y is equal to x cubed minus 4. And remember, same deal. You always just switch the x and y. So y cubed minus 4. And then you add 4 to both sides. So x plus 4 is equal to y cubed. So I'm just going to rewrite it to the other side. So y cubed is simply x plus 4. And if you just want to solve for y is now simply the cube root. So you can do the cube root. So this is the cube root. That's how you write the cube root. Or another way you can write it is simply x plus 4 1/3. They both mean the same thing. So if you write this or that, it's basically the same thing. So that's how you find f inverse. Oh wait, sorry. So that's not right, because the last step is f inverse of x is simply equal to x plus 4 cube rooted. And this should be our solution. So never leave it in terms of y, leave it in terms of f inverse of x, because that's exactly what they're asking for. Okay, let's move on to the next one. We only have a few more to go. Okay, so let g of x equals 3x minus 2, and h is equal to that. Now, I know you may have never seen, this is known as a rational function. You may have never seen a rational function before, but that's okay. It doesn't really matter. Because we're just trying to find h of g of x. Just focus on the principles here. So h of g of x means h of g of x, and so it's like this is 3x minus 2, so h of 3x minus 2. And as always, all you do is you take this argument and you plug it into x over here, and you plug it into that x over there. Right? That's all you're doing. That's all you're doing. It's just you're taking this argument and plugging it into the x over there. So this is equal to 5 times something over something minus 4. And that something happens to be 3x minus 2. And this is 3x minus 2 over here. So this is equal to 15x minus 10 over 3x minus 6. And that's it. You don't have to do anything more. They just asked you to find h of g of x and simplify. Actually, can this be simplified? 5. No, I don't think it can be simplified any further. So 5. Actually, it might be. Let me just check. So if you want, if they ask us to simplify, we take out the factor of 5, so it's 3x minus 2, and then if we take out the 3 over here, it's 3x minus 2. No, this can't be simplified because you can't cross these out because that's not a 3. So I would have just left it in this form, 15x minus 10 over 3x minus 6. So this is sufficient. Okay, solve the equation. This is equal to 0. So I just need a little bit of room. So here, I'll just write it all over here. So it's really 15x minus 10 over 3x minus 6. So they're saying this is h of g, and they're saying set it equal to 0 and solve it. So if you're trying to solve it, all you have to do is multiply the denominator here on both sides, and if you do, 0 times that will simply be 0. So in other words, 15x minus 10 is equal to 0. Like, I hope you understand that all I did was I multiplied both sides by 3x minus 6, and I multiplied this side by 3x minus 6. The thing is, you can cancel these two sides out, so you're left with 15x minus 6. And over here, it's 0 times that, but 0 times anything is 0, so that's why you get that. Anyways, so 15x is equal to 10, and so x is equal to 10 over 15, which is basically 2 over 3. So that's the solution for b, which is 2 over 3. Okay, I'm going to erase this because I need to make room for number 10, but you can always scroll back and see how I got the solution for that. So I'm just going to erase this right here. Okay. Oops, okay. X is equal to 2 over 3. Okay, let's go on to number 10. The functions f and g are defined by this. Remember, as we said, this is almost exactly like the problem that we did. Let me just scroll back. This is almost exactly the problem that we did here. Which is, no, it's not almost exactly, it is exactly. So it's number 7. So all you have to do is just go to number 7, and then you'll see the same solution. So I'm not going to do it again because all you have to do is just scroll back to number 7 and you'll see how we got number 10. Okay, number 11. Let f of x equals 2x plus 1 and g of x equals 3x squared minus 4. Find f inverse of x. Okay, so let's do that. So basically if we look at this, so it's y is equal to 2x plus 1. You switch x and y, so x equals 2y plus 1, and then you solve for y. So it's x minus 1 is equal to 2y, so y is equal to x minus 1 divided by 2. So f inverse of x is equal to x minus 1 divided by 2. So that's that one. Now, g of f of negative 2. So let me do that. G of f of negative 2. So g of f of x. Remember, the best way to do this is find what g of f of x is, and then finally plug in negative 2. So this is equal to g of 2x plus 1, sorry. 2x plus 1. And remember, as always, you just take this argument right here, and you plug it into g, you plug into the x value of g, right? So that's going to equal to 3 something, that something is the x, something squared minus 4, and that something happens to be 2x plus 1. So this is, I wouldn't expand this. I would not expand this, I would just leave it like that. So now we found g of f of x, now we have to find g of f of negative 2. So g of f of negative 2, all you have to plug in is negative 2 into the x. So 3 times 2, I'll write this in red, times negative 2 plus 1 squared minus 4. It's equal to, this is negative 4 plus 1. Negative 4 plus 1 is negative 3, so 3 times negative 3 squared minus 4. Negative 3 squared is 9, and 9 times 3 is, and it's positive 9, by the way, not negative 9. Negative 3 squared is 9. 9 times 3 is 27, so it's 27 minus 4, which is equal to 23. Let me just double check this to make sure I have this right. Yeah, it looks good so far. Negative 4 plus 1 is negative 3. That squared is 9. 27. 27 minus 4 is 23. So this is equal to 23. Okay. Finally, find f of g of x. Okay, that's pretty straightforward. I'm just going to erase this part because I just need some room. So you can always scroll back and see how I did that solution. So let's do this one. So f of g of x. Okay, so it's f of g of x, right? So it's equal to f of g of x is 3x squared minus 4. 3x squared minus 4. And as always, just take the argument here and plug it right into the x over there. So it's equal to 2 times something plus 1, and that something happens to be the argument right here. So it's 3x squared minus 4. And I would just simplify it in this case because it's not too much trouble. So it's 6x squared minus 8 plus 1. So it's equal to 6x squared minus 7. And that's the solution for this one. So it's 6x squared minus 7. Let me just double check to make sure I've got this right. So 2x plus 1. So 6x squared minus 8 plus 1. Yeah, okay, so this is definitely right. Okay, so again, I'm just going to erase it right here because I just need the room. But you can always scroll back and see how I got that solution. Okay, let's go to number 12. So same thing as before. If you ever see that notation, it just means f of x equals 4x minus 1, and then g of x is equal to 6 minus x over 2. Okay, so find g inverse. Okay, they really should have said g inverse of x. Not sure why that didn't come out properly, but anyways, find g inverse of x. So here's our g inverse. Let me just use blue again. So y is equal to, or g of x, sorry. Y is equal to 6 minus x over 2. Switch the x and y, so x equals 6 minus y over 2. Multiply 2 on both sides, so 2x is equal to 6 minus y. And then you can solve for this, so y is equal to negative 2x plus 6. All I did was I added y on both sides and I subtracted 2x, and so that's how we end up. But remember, the final step is to write g inverse of x is equal to negative 2x plus 2. So this is equal to negative 2x plus 6. Sorry, I don't know why I said 2, but negative 2x plus 6. Okay, solve the equation f of g inverse of x is equal to 4. Okay, so let's do that. So f of g inverse of x is equal to 4. So the first thing you have to do is find what f of g inverse of x is. So we just found that g inverse of x is that. So f of g inverse of x, okay, is equal to f of negative 2x plus 6, so negative 2x plus 6. And remember, as always, all you're doing is you're taking the argument and plugging it right into that x, okay? So this is equal to 4, and it's something minus 1, and that something happens to be this argument right here. So it's negative 2x plus 6. So let's simplify this. This is equal to 4. I'm going to simplify in the brackets first. So negative 2x plus 5. Okay, and if I expand that, it's equal to negative 8x plus 20. Now, this is what f of g inverse of x is. Remember, they asked us to solve it. So notice this expression is actually, this expression is actually equal to 4. You'll see my Word document open up in a second, or it might. But anyways, ignore that. In other words, this expression right here is equal to 4. So f of g inverse of x, which is equal to negative 8x plus 20, is equal to 4. So all we have to do is just solve for x. So this is actually quite straightforward. You can subtract negative 20 from both sides. So negative 8x is actually equal to negative 16. And then divide by negative 8 on both sides. So negative 16 divided by negative 8, which is equal to positive 2. Okay, so the solution to this one is x equals 2. Okay, so once again, I'm just going to erase all of this because I need some room for the other questions, but it's the same old thing. You can always scroll back and figure out how I did that. Okay, so okay, all right, so let's do number 13. So f of x is equal to 3x plus 5. So let me just write that down there. F of x is equal to 3x plus 5. And g of x is equal to 2, 1 minus x. Okay. First find f inverse of 2. So this is y is equal to 3x plus 5. X is equal to 3y plus 5. So this is x minus 5 is equal to 3y. And then we divide by 3. So y is equal to x minus 5 divided by 3. And so f inverse of x is equal to x minus 5 divided by 3. Now, they didn't ask us for f inverse of x. They asked us f inverse of 2. So we just have to plug that in. F inverse of 2 is equal to 2 minus 5 divided by 3, right? Which is equal to negative 3 divided by 3. I just need some more room, which is equal to negative 1. So the answer to this is negative 1. So this is equal to negative 1. Okay, next do this. G of f of negative 4. So in order to find first find g of f of x. So g of f of x. And so it's equal to g of f of negative 4. Okay. And sorry, why am I doing negative 4? We're trying to do x first. So let's do that. So f of x. And f of x we said is 3x plus 5. So it's g of 3x plus 5. And remember, as always, we take the argument right here. And then I'm going to go through and we're going to plug it right into that x over there. So what that means is equal to the 2 over here times 1 minus something. What is that something? It's 3x plus 5. And I highly suggest that when you put that something, you put that in brackets. So that way if there's a negative in front, as we'll see, you never make a mistake. So this is equal to 2 times 1 minus 3x minus 5. Okay, so it's equal to 2 times 1 minus 5, or this is negative 3x minus 4. Okay, now we can go on further, we can simplify this further, but that's not what the question is asking for. The question is asking for g of f of negative 4. So once you get to some sort of expression, you can just start plugging things in. So they want g of f of negative 4, which is equal to 2 times negative 3 times negative 4 minus 4. So it's equal to 2, negative 3 times negative 4 is 12. 12 minus 4 is equal to 8. So it's 2 times 8, which is equal to 16. So the answer to this one is 16. All right? So once you find g of f of x, then just basically plug in negative 4, and that's our solution. Okay, let's move on to the next one. Number 14. Consider the functions f and g, where f is that and g is that. Okay, find the inverse function. Okay, so of f. So y is equal to 3x minus 5. Switch x and y, so x equals 3y minus 5. So it becomes x plus 5 is equal to 3y, and so y is then equal to x plus 5 divided by 3. And remember, we don't leave it as y because we have to, it's really f inverse of x is equal to x plus 5 divided by 3. So this is equal to x plus 5 divided by 3. Okay, I'm just going to erase this because I need to make room for the rest, but you can always scroll back and see how I did that. Okay, given that g inverse of x is x plus 2. So in other words, they've just done it for us. Find g inverse of f of x. Okay, so g inverse of f of x, okay, and g inverse is, oh sorry, f of x is 3x minus 5, 3x minus 5. You, again, as always, you take this argument and you plug it into the g inverse. Our g inverse is right here, so you're going to plug it into right there, that x over there. So it's equal to 3x minus 5 plus 2, which is equal to 3x minus 3. And that's the solution of this. So it's 3x minus 3, because the negative 5 plus 2 is negative 3. Okay, now what I need to do next is, okay, so it's 3x minus 3, and okay, I'm going to erase this because I need some more room. But remember, as always, you can scroll back and figure out how I've done this. Okay, so given that f inverse of g is equal to this, solve f inverse of g of x is equal to g inverse f of x. Okay, so f inverse of g is pretty much what they gave us right here, right? So this part right here is simply x plus 3 divided by 3. Then there's an equal sign, okay? And g inverse of f of x, which is this part right here, which is what we found, is 3x minus 3. So now this is actually a really easy question, because all we have to do, this is basic algebra, all we have to do is solve this equation. So what we do right here is we multiply everything by 3, so it's x plus 3 is equal to 9x minus 9. It's 9 because 3 times 3, 3 times all the 3's over here is 9. And then now just get all the variables to one side and the constants to the other. So this is going to be 3 plus 9 is equal to 9x minus x. So this is going to be 12 is equal to 8x. So x is equal to will be 12 divided by 8. And 12 divided by 8, if you divide by 4 on both of these, it's basically 3 over 2. Right? So this is so here x is equal to 3 over 2, or if you want to write it as a decimal, that's fine too. That's 1.5. Okay? So that's a solution for C for this one. Now let's go to number 15. Number 15. Okay, so let f be this function given by, and it's from 0 to 3.5, as this diagram shows. Okay, so you may have never seen this function before, but that's okay. You know what the beauty of this question is that they've given us the graph. So we don't even need to know what this function is. Well, I mean, unless the question really requires us to, but this question won't. And we have this graph. So it says, on the same diagram, sketch the graph of f inverse of x. Well, we can do that because all we need to do is just get a list of x, y. So here, so see this point right, so let's just get a few points. All you really need is just a few points. So let's get this point right here, and let's get the end point right there. Okay, so if I get this list of x, y, this point is 0, 1, so 0, 1. This point right here is 2, let's just say that's like 2.7, so it's 2.7, okay? And then finally, the last one is 3.5 by, say, 5.5. And it's 3.5 because we know that's 3.5. And let's just say that's, say, 5.5, roughly speaking. So it's 3.5 by 5.5. Now, if we're applying, now the question says, on the same diagram, sketch the graph of f inverse. So f inverse just means that we switch the x and y. So what will our new plot look like? Well, all we're doing is just switching the x and y. So this becomes 1, 0, 2.7 and 2, and then this becomes 5.5 and 3.5. All right, so let's plot these points. So 1, 0 is right here. Let me actually do this in a different color. So 1, 0 is right there. 2.7, and 2 is like somewhere right there. And 5.5 and 3.5 is somewhere right there. So it's like that, right? And you're going to stop right there because this stops right there, so that has to stop right there. So I'm actually just going to erase it just a tad little bit right there. So maybe, yeah. So you're going to stop right there because this doesn't go any further, so you're not going to continue any further. So it's very, very important to remember that. And once again, the other thing that I kind of want to emphasize is there's a reflection, because this is the inverse, there's a reflection across this line, which is y equals x. So if you reflect this line over y equals x, which is this line over here, you will get this green line, all right? And that's the important thing for finding the inverse. Okay, so let's continue. So write down the range of f inverse. So if you remember, the domain of f, right? The domain of f is the range of the inverse. So, and we also know this is an easy question because they sort of write down. So the way you do this is the domain of f is from 0 to 3.5, so the range of f inverse must be the same, 0 to 3.5. And let's just make sure they put that there. Yep, perfect. So this is the range, and that's it, as easy as pie. Okay? All right, number 16. On the diagram below, shows some graph of f, so this is f. Same diagram, sketch the graph of f inverse. Same deal as before, okay? Just get a few points and sketch it. So let's take this point right here, and maybe this end point right there, okay? So if we get our xy, okay, so this is like close to 0, so let's just say it's 0.1, negative 2, so 0.1, negative 2. This one is 1, 0, 1, 0, and this one is, say, I would say somewhere around 2.5, so 2.5 and about, say, 0.8, 0.8, good. Okay, so we do that, and so this is negative 2, 0.1, 0, and 1, and this is 0.8 and 2.5. All right, so let's basically sketch this out. So this is negative 2, 0.1, so it's like that, okay? This is 0 and 1, so 0 and 1 is like that there, and 0.8 and 2.5, which would be somewhere like that, and if I were to sketch it, it would look something like that. So the thing is, in this case, I can sort of extend it forever because here they have really no limitations and they've not given us a domain or a fixed domain or a fixed range, so I can just sort of go beyond, and that's fine. The thing to remember here, once again, as always, when you're finding the inverse, remember that there's a reflection across this line, which is y equals x, and so that's the reflection. So this reflected across this line is that green line right there, and that is the sketch of f inverse. Okay, now let's go to our very last question, which is number 17. Okay, so let's look at this. So the diagram below shows three graphs. A is part of the graph y equals x. So this is y equals x. So whenever you see y equals x, right away that should be a clue. It has something to do with the inverse. B is a part of a graph of y equals 2x. So in other words, this is y equals 2 to the power of x. Now, you've never seen this function before, but that doesn't matter because we have this graph. And intersects the y-axis at 0, 1. So there's this point right here, which is 0, 1. Okay. C is the reflection of graph B in line A. So in other words, if we take B and reflect it across A, we're going to get C. Write down the coordinates of the point where C cuts the x-axis. Now this might seem confusing at first, but remember that if this is 0, 1 here, right, and if it reflects across the y equals x, it will be right here. And this point, it'll just have the xy switch, so it's going to be 1, 0. So, and this 1, 0 also just happens to be the x-intercept. It's where it cuts the x-axis. So the solution to this is simply 1, 0. Okay? So that's the important subtlety you have to remember, that you have to switch x and y and it maps to a different point. And if you ever see a question like this, it's really not that hard. It's really quite easy because all you have to do is just switch the x and y and you'll notice, voila, it's right over there. Okay, so that's the solution for this problem set, and I guess I'll see you in the next video. Take care. Bye.